All right, we're back and we're going to talk about the domain and range again, this time of not of discrete, but of continuous variables. All right. Remember, the domain is just really all possible values of x, which are all the inputs, the range, all possible values of y, which are really just the outputs. I'm going to do this by way of example this time. All right. So I have this graph and it is continuous because there is a straight line that's going there between them, right? Straight line between them. Notice that the endpoints, and let me make it a little bit bigger just for this purpose for right now. Let's take a look at these endpoints. The endpoint here is an open circle. That means you do not include it. This is a closed circle, which means you do not include it, right? We learned that when we talked about inequalities. Okay. Now, there are many ways of looking at this, but here's how I look at it. Since I'm talking about the domain, I'm worried about the values of x, right? And all of my x's are going to be in between some number and some number. It's going to go from here to there. It's all the possible values of x. So one way I can look at that is that if it's going to be between two things, it's going to be greater than some number, but at the same time, it's going to be less than another. So every time I have a domain problem, the very first thing I write down is just x and then put two of these things right away. Okay, I'm going to erase that second one because it's unnecessary, but just trying to make the point. Okay, now let me see if I can fill this in. Over here, I'm looking for all the things that are all the way to the left. You see how it's kind of going to the left here? If I were to go to the left, as far as I can go on this function, so if I just follow it, follow it, that's as far as my function goes. What is the x value right there? Yep, that's a 0. So it goes as far as left as 0. Okay, let me erase my line here so I can see it better. Now, how far to the right do I go? Well, if I follow this function again, and I'll just keep following it, the furthest to the right it goes is right here. That's 1, 2, 3. So it goes as far right as to the 3. Now, the last thing I need to do is, that's where it falls in between. I need to know what happens at the actual endpoints. So at 0, and x is equal to 0, do I include it or not? Well, on the function, it's a closed dot, so that means I do. So I need that underline thing. Let me do the same thing at the other end, on the upper end. It goes as far to the right as 3. Do I include that at 3? Well, by looking at this function, it's open at 3, so I don't include it. That's going to be my answer. So if I look at this, I'm looking for 0 is less than or equal to x, which is less than 3. It would be this one. It's not this one, even though they both have a 0 and a 3. It's saying that you do not include 0 and you do include 3. That's opposite. All right. For the range, let's just say I look at this thing, the same exact diagram. I'm going to do the same thing for the range, right? Let me make it a little bit bigger. Now I'm talking about the y's. The range implies the y's. So I immediately do this. Now, if I follow this thing all the way to the left, boom. Where on the y value, the y-axis, the up and down, where do I go? Oh, that's right here. That's at -2. If I follow it and go all the way to the right, as far as I can go, oh, it stops right there. Where is that on the y-axis? That's at +1. Now, as far down as -2. Now, how far up does this thing go? Up as high as 1. I just need to see what happens at each individual spot. So let me get rid of this line so I can see. Okay, come on. All right. So at -2, it's a solid dot. That's as far as it goes, and it ends at a solid dot, so I include it. At +1, the function is an open circle, and so I don't include it. I'm looking for something that looks like that. Y is between -2 and 1, and it includes -2. So -2, y, 1 looks like this one. When it's continuous, you're going to have domains and ranges that have these inequalities. It's continuous, see, because it's solid, and you know your options are that. Same thing here. The domain and range may be this. Ooh, let's do this one very, very quickly. Just the domain. The x's, I'm looking at my clock here, I have 20 seconds. It goes as low as, so if I follow this function, it's going to go on forever. That goes to -infinity. If I were to follow it to see how high it goes on forever. That's +infinity. That's the same thing as saying all real numbers. It goes all the way down